Okay, in the previous lecture we looked at example 38 where we calculated in two different approaches or used two different approaches to calculate the final payment for Dr. van Rooyen's loan. So we are going to move on to example 39 now, which is a very similar example. Let's look at this example. A building contractor secures a loan of R1 million from a financial institution. The institution fixes the interest rate at 18% per annum compounded monthly. Loan repayments are to be made monthly starting 1 month after the loan is secured. The contractor budgets for monthly payments of 16,100 rands. Determine the number of the monthly payments and then also the value of the final payment. Okay, so a few things that we need to notice here. First of all, you have to recognize this as a simple annuity. And why do I say that? It's because our interest rate is 18% per annum compounded monthly, and the loan repayments are to be made monthly. So the previous example was a complex annuity, and this is now an example of a simple annuity. So we need not calculate the equivalent effective interest rate. Okay, and then we have to do two things. We have to first of all calculate the number of monthly payments. So that is, you can consider that as revision from chapter 2. And then after that, we want to calculate the value of the final payment. So if the number of monthly payments is not an integer, then the value of the final payment will be less than the 16,100 rands, and we would like to calculate the value of that final payment. Okay, so we start out by calculating the number of payments. What the information we have that the present value is R1 million. That's the loan size. Then we know that our interest rate is 18% per annum and it's compounded monthly. And we know that the monthly payment is equal to 16,100 rands. And we would like to calculate K, the number of payments. Okay, now remembering from chapter 2, so this is nice, we can do a little bit of revision from chapter 2. From chapter 2, we know that, or we start out with the present value of an annuity. Okay, and now we will rearrange this formula to find K, the number of payments. Okay, so first of all, I will divide on the left and on the right with the payment value. And then I will also calculate on the right and on the left, I will calculate with this interest rate. So on the left, this is what I have on the left, and on the right, I will be left with this. Okay, and now I will just move this part to the left and this to the right. So I will just move that to the left and that to the right. So on the left, I will have and then on the right. Okay, and now I will make use of the LIN, the rules of logs, to find my K, or to rearrange it so that my K is on ground level. So on the left, I take the LIN. And if I do that, I can move that minus K to minus K times ln 1 plus Im. And therefore, I also need to take the ln on the right-hand side. And then, of course, if I want to solve for K, I will divide on the left and on the right by that factor. So on the left it will cancel out, and then on the right I also need to divide by that factor. And of course I don't want a negative k, I want a positive k, so to make that a positive I multiply it with -1 and therefore also multiply with -1 on the right. Okay, so this formula should look familiar from what we've done in chapter 2, and now we can just do our substitution, which we will do on the next page. And of course this 0.015 is just my effective monthly interest rate, the 18% divided by 12. And if we calculate this, we get for K 180.239. So we will make 180 full payments of 16,100 rands, and then the 181th payment will be less than this. It should be considerably less than 16,100. Okay, so this part is actually revision from chapter 2. So next I will now look at how do we find the value of that final payment. Okay, so let's start with a timeline. At time t0, I have my original loan of R1,000,000. Then I make my payments of 16,100 rands, and I make 180 full payments, and then at time t181 I will make a final payment which should be less than 16,100 rands. Now we looked at two methods to solve this. The first method is to move all the payments to time t0 and set that then equal to the loan size at time t0. The second method is to move the loan to time t181 and set that equal to the value of all the payments at time t181. Okay, so let's just first start with the first one. I'm going to do both of them just for completeness sake, and we'll give you some extra exercise. Okay, so first of all, we can say that the loan of R1,000,000 is equal to the value of all the payments at time t0. Now all the payments will be my annuity, the present value of my annuity. So the present value of my annuity is equal to the following. And my K is 180. And then also the value of my final payment that I move to time t0. So this is a single amount that I move. I make use of the formula for compound interest. And I move it back 181 time periods. Okay, and you can now calculate this and subtract that from your R1,000,000, divide it by this part, and that should give you your final payment of 3,870 rands. Okay, and you can see we expected that this final payment should be considerably less than 16,100 rands because of this decimal part that is very close to 180. So that's the one way of solving this problem. The other way of solving this problem would of course be then to move the value of the loan and the value of all the payments to time T181. So let's quickly do that. I can move my original loan. I will move it from time T0 to time T181. It's a single amount, so I make use of the formula for compound interest. And I move it 181 time periods. Now, the value or the future value of my annuity is calculated when the last payment is made for the annuity. So the future value of an annuity will bring me to time T180, and then I will have to move it a further one time period to time T181. So the future value of my annuity is the following. That's the future value of my annuity at time T180, and then I still need to move it one time period to time T181. That's a 0.015 if you can't see that clearly. And I move it only one time period. So this is the future value of an annuity, and that is the value, or that is the formula for moving a single amount one time period forward. Okay, and then plus F, the final value of, or rather the final payment. I don't have space here, and I think the rest of this is actually trivial. You just need to solve for F from this, so you can just plug this all into your calculator and calculate the value of your final payment, and that should come out the same as this answer here, perhaps with 1 or 2 decimal difference just because of rounding off. Okay, so now we are in the position to attempt some more exercises at the end of this chapter 3. So if you go at the back of chapter 3, the exercises on section 3.1 to 3.3, you should have done numbers 1 and 2 already. Now you should be able to do numbers 3, 4, and 5 as well.